So today we're going to talk about quadrilaterals and parallelograms. What is a quadrilateral? Anybody? So we said quad means four, so the key word is four. So a quadrilateral is a shape that has four sides. And so we're going to have this big heading, and you're just going to draw a random four-sided shape. And this is our main heading, quadrilateral, and everything else that we're going to talk about today is going to fall under this heading. All right, and a quadrilateral is defined as having four sides. That's it. They don't have to be equal, they don't have to be the same size or shape or anything, just has to have four sides. There's two main types of quadrilaterals. The first one is called a trapezoid, and it's going to be over here kind of by itself. It's its own thing. It's the only thing that's going to be on this side of our drawing. And a trapezoid has two sets of parallel lines. All right, so the top and the bottom are parallel, but that's it. So a trapezoid is defined as having exactly one pair of parallel lines. And the other type of quadrilateral is a parallelogram. And so this side over here that we're going to make now is going to have a lot of things underneath it. So a parallelogram usually looks something like this. And we're just going to pretend that these are parallel, even though they don't really look exactly parallel. But a parallelogram has two pairs of parallel lines. So there's three types of parallelograms that we're going to talk about. We're going to talk about rectangles, squares, and rhombuses. So the first one is a rectangle. And a rectangle has four right angles. And then just like a parallelogram, it also has two pairs of parallel lines. And I'm going to use those two L's to represent parallel lines. All right, the next one is a square. Nope, I didn't do it. I'm going to try to make it look like a square. Okay, so a square is defined by having four right angles and four congruent sides. Okay, because remember that all the sides in a square are the same size. And then they also have those two pairs of parallel lines. And then the last type of parallelogram is going to be a rhombus. So a rhombus is like a square that's kind of been like made crooked a little bit. It looks very much like a parallelogram, but all the sides are the same size. Whereas a parallelogram is more like a rectangle. A rhombus is like a square because all the sides are the same size. Okay, it's not drawn yet, but you'll see. Okay, so we're going to say has 4 congruent sides. And opposite angles in rhombuses are congruent. So this angle would be equal to that angle, and then this angle is going to be equal to that angle. And then it has the other features of a parallelogram where the two has 2 pairs of parallel lines. Opposite sides are parallel. Okay, so we're going to talk about properties of parallelograms now. There's 4 properties we're going to talk about. Property 1 is the opposite sides of parallelograms are congruent. Property 2 says opposite angles of parallelograms are congruent. So property 3 says consecutive angles of parallelograms are supplementary. That means consecutive means they're right next to each other. So if you take 2 of the angles that are next to each other, for example, this angle plus this angle, they're going to add up to equal 180. That's what that means, okay? You could do the same with these 2 angles on the top. Those would add to 180 also. As long as they're next to each other, they're going to equal 180. Property 4 tells us that the sum of all the angle measures in a parallelogram equals 360 degrees. So remember, the sum of the angles in a triangle is 180, but the sum of the angles in a 4-sided shape is going to be 360 degrees. And now we're moving on to properties of diagonals. And a diagonal is just a line that goes from one side of the parallelogram to the other. Okay, and there's always going to be 2, because you're just connecting the 2 opposite angles together. Those are the bisectors or the diagonals. And in a parallelogram, they bisect each other, which means that this piece is equal to this piece, just cuts it right in half, and this piece is equal to this piece. But those 4 pieces do not equal each other. Only in a rhombus do they equal each other, and a square. All right. Okay, so here's the last 2. The diagonals of a rectangle are congruent, so they would all equal each other. And the diagonals of a rhombus are perpendicular. So remember, the rhombus is like that square that's been kind of smushed sideways a little. All the sides are the same size. So the diagonals in that rhombus meet at 90-degree angles. And then, yeah. All right, so those are all the properties that we have for today. So now we'll work on some examples. Okay, so now we're going to do some examples from page 218. And for numbers 1, 2, and 3, it has this drawing, parallelogram ABCD, and it says the measure of angle A is 42 degrees. So I'm going to use that to find other information in this parallelogram. So number 1 says, find the measure of angle B. You know how to do that, James? How do you think you do it? Okay. Okay, so we just figured out that angle C has to be 42 degrees because if we go back here to property number 2, opposite angles of parallelograms are congruent. So I can look at my parallelogram and I know that the angle across from A is going to be the same size, 42 degrees. Now, we already talked about how all the angles in the parallelogram add up to 360 degrees. So how can I find what angle B and D equal?
42 plus 40.
So we just talked about how to find the other 2 angles in our parallelogram. We know that all the angles add up to 360 degrees. So we added 42 plus 42 and got 84. Then we subtracted that from 360 and got 276. Then we divided that in 2 because we have two angles that equal 276, and we got 138. So that means that angle B is how much?
38.
Angle C?
38.
What?
Oh, 42.
And angle D?
38.
There we go. Okay? So whenever I do these types of problems, I always work it out in the actual figure first, and then worry about answering the questions after. Once you find all that information, the questions are the easy part. For numbers 5 through 10, it gives us this rhombus, and it tells us to find the length of each segment. Now I know this is a rhombus because it looks like a, and actually mine doesn't look like a rhombus, mine just looks like a square that's tilted, but in the book it looks like a square that's kind of been like slanted a little. And I know it's a rhombus because these two sides are 10. Remember, opposite sides are congruent in parallelogram, so that means this one's 10 and this one's also 10. So what do we know about the diagonals now? What do I know about these two pieces of this diagonal? They're equal.
So it's 8.
So this side is also going to be 8, and then what about this other diagonal?
6.
Yes. So those two sides are going to be the same size also, so that means this one's going to be 6. So now we can just fill in all the answers. So EH is how long? How long is EH?
EH. 18.
10. How about HG?
Oh. 10.
10. How about DG? 8. How about EG?
8.
Careful.
Wait.
16.
Yeah,
EG. Yep. And how about FD? FD. 6. And FH. There you go. There's the 12. Okay. So I fill in all the numbers on my shape, and then I can easily answer the questions. Okay, so I'm going to do a few examples from IXL just to give you an idea of what to do. It says, can you show that this quadrilateral is a parallelogram? Think about the properties we just talked about. Can you prove that this is a parallelogram?
Yes, because they're equal.
Because the bisectors are equal. Okay, yes, it is a parallelogram. Can you show that this quadrilateral is a parallelogram? Yes, because opposite sides are congruent.
So, like, wait, this one wouldn't be one, right? It's 6, 3, 6.
All right, can I show that this quadrilateral is a parallelogram?
Yes.
If these two are 220,
And 70, and 70 and those
290, and if we did 70 more, that would be 360. So yes, it adds up to 360. It's a parallelogram.
What if you have just two numbers on the side?
This one says find the value of t that makes quadrilateral PQRS a parallelogram. Well, we know from our properties that the opposite sides of parallelograms are what? Equal. So then I can make an equation just putting these two sides equal to each other and find out what t equals. So 15t equals t plus 14, and then I'm just going to solve. I'm going to minus t and get this t over here. And then I'm going to divide.
I'll put my laptop away.
Yes. All right, so t equals 1.
Can you go back to that?
Yeah. All right. Let me pause this.